Hi guys, I'm Nivita. In this video we are going to see about domain. Okay, so first of all we will see the definition of domain. If f is a function, okay, if f is a function, then the set of values of x where f of x is defined is called the domain. Okay, which means, so here we are having some elements and here also we are having some elements. Okay, so domain means this is a x and we are applying a function and we are getting f of x. Okay, so the set of values of x where we can find f of x, that is refers to as the domain. Understood? The set of values of x where f of x is defined. For this value f of x will be defined. So this is called domain. Understood? Suppose if you are considering the function as 2x square plus 5x plus 5. Understood? So the x value will be any real numbers, right? So the domain of the function is equal to real numbers. Okay, we can apply the real numbers in this. So that is what domain is. Now we are going to see rational function. Now we are going to see what is rational function. Rational function means, suppose if you are considering f of x as a rational functions, which means it has two functions in the numerator as well as in denominator, where the denominator should not be equal to 0. Okay, suppose if it is 0 means it may goes to infinity, right? So it is not valued. So the thing is, the rational function means that function will have numerator as well as the denominator, where the denominator should not be equal to 0. Okay, we have to take a value which should not satisfy this equation. Okay, that is what the domain is. Okay, I will tell you some examples of this rational function. Suppose if you are considering f of x, to be 1 by x minus 1, the domain of this function is real numbers minus 1. Because suppose if you put 1 here, no. So you will get 1 minus 1 is 0. So 1 by infinity you will be getting. So except 1, you can take any values. That is what you are trying to tell. Understood? Except 1, you can take any values. That is what you are trying to tell. Then we are going to see f of x is equal to x plus 1 divided by x square minus 5x plus 6. So here the denominator is in square, right? So we can form a root, like 6 means what? 2 into 3 will come. Okay, minus 2 minus 3 will come. So I can write this as x plus 1 divided by x minus 2 into x minus 3. X minus 2 into x minus 3. Here I already told you the denominator should not be equal to 0. So the domain, we can take the domain as real numbers minus 2, 3. Because if you take 2, no, you will get a 0. So denominator will be 0. So anything by 0 will give you infinity. Same like if you put 3 here, the denominator will become 0, right? So the domain of this function should be real numbers minus 2, 3 should come. Understood? Then we are going to see the second condition, which is suppose if you are considering a function f of x to be root of g of x. This is one function and this is one function. Okay, f of x is equal to root of g of x means we can write the domain as set of all x such that g of x should be greater than or equal to 0. That is, this function should be greater than or equal to 0. Understood? So suppose, for example, I am considering the f of x is equal to root of x square minus 3x plus 2. Here the g of x value would be this, right? So g of x value would be x square minus 3x plus 2. Actually, this value, what is the condition is, this value should be greater than or equal to 0. Therefore, what I am going to do is this value should be greater than or equal to 0. Okay, if you factorize it, you will get 2 into 1. Okay, so it's like x minus 2 into x minus 1 will come for g of x. If you factorize this, then that value should be greater than or equal to 0. Understood? Then you have to find the value of x. So here the x value will be like greater than 2, greater than 1, likewise. Okay, suppose if you are having a function like x greater than or equal to a, x greater than or equal to b, like this type of function means you have to check what is the greatest number. Okay, according to that you have to put. Therefore, x belongs to minus infinity comma 1 union 2 comma infinity. Okay, 2 comma infinity. In for infinity it should be a open bracket. For this 1 and 2 you have to get a closed bracket. The thing is, the x value will be like 2, the x value will be like 1. So here the greatest value is 2, right? So it should come like 2 comma infinity. Okay, the less value we have to consider as minus infinity to 1. Understood? So here the thing is f of x is equal to root of g of x. When the function f of x is in the format of this, the domain, we have to find the domain by g of x should, we have to consider the g of x should be greater than or equal to 0. So if you substitute the values now, you will be getting this. Here both the terms are greater than or equal to 0. So we have to write the greatest term as like this 2 comma infinity and the lesser term like minus infinity comma 1. So that is what your domain is. Understood? Okay, here we are going to see the third condition. See this function f of x is equal to 1 by root of g of x. In last example, what we have seen is f of x is equal to g of x, root of g of x. In this condition, what we have to take is the domain as g of x should be greater than or equal to 0, right? Greater than or equal to 0. But here, when it is in denominator, you can just show it is greater than 0, not equal to 0. Understood? When the function is in the format of this, like 1 by root of g of x means, the g of x should be greater than 0, that's it. So consider the function f of x as 1 by root of x minus 1. Here the value of g of x would be like x minus 1. That should be greater than 0. Therefore, x should be greater than 1. We have to bring this minus 1 this side. See here, x is greater than 1 means definitely what would be the domain? X belongs to 1 comma infinity, right? Because x is greater than 1 means you have to include like x belongs to 1 comma infinity. Understood? Suppose if the f of x value as log of g of x, suppose the function f of x value like log of g of x means that the domain will be like set of all x such that g of x should be greater than 0. Okay, this is a function, no? So here this function should be greater than 0, right? Understood? So listen, suppose if you are considering f of x as log of x minus 2 base 10. Okay, here the g of x value as x minus 2. The condition is the g of x should be greater than 0. So the g of x should be greater than 0. So which is x is greater than 2 will come. Understood? So the domain of the function will be like 2 comma infinity will come. See, f of x value as log of g of x. To find the domain should be greater than 0. F of x is equal to log of x minus 2 base 10 will come. Here g of x value will be like x minus 2. In this example, the g of x value will be like x minus 2 when the function is in the log. Okay, when the function is in the log, what we have to do is we have to take this term should be greater than 0. So x is greater than 2, x is greater than 2, obviously domain should be 2 comma infinity. Okay, here we are not having equal, no, so you have to use the open bracket only, not closed bracket. Okay, suppose we are going to see the fifth one, which is suppose if you are having the function f of x as 1 by log of g of x. Okay, compare this. This is just log of g of x. This is 1 by log of g of x. Okay, then what will happen is the function, you have to take the function as set of all x such that g of x should be greater than 0 and g of x should not be equal to 1. This is a two condition when you are having a function which which is in denominator, okay, in the format of 1 by log of g of x means what you have to do is the domain of f of x. Domain of f of x is set of all x such that g of x should be greater than 0 and g of x should not be equal to 1. Understood? So here what I am going to do is, see, the function as 1 by log of x minus 3 base 10. Okay, the condition here is g of x should be greater than 0 and g of x should not be equal to 1. So here the g of x is x minus 3 should be greater than 0. Therefore, x is greater than 3 and x minus 3 is not equal to 1. Definitely x is not equal to 1 plus 3, right? I am bringing this 3 this side. So, x should not be equal to 4. Understood? See, compare these two things. X should be greater than 3. If you are considering a number line, no. So, it's like greater than 3 and it should not be equal to 4. There is one 4 here, no, that it should not be equal to 4. What I can do is for the domain, I can write it like 3, 4. It's like we should not include 3 also and we should not include 4 also. Union, we should not include 4 up to infinity. Okay, so the thing is f of x is equal to 1 by log of x minus 3 base 10. Here the g of x should be greater than 0, g of x should not be equal to 1. That is what the condition. Okay, so x is greater than 3 and x is not equal to 4. It will be like 3, 4 union 4, infinity will come. Understood? So thank you for watching. Sorry, finally we are going to see one thing, which is suppose if the value of f of x as root of log of g of x base a. Okay, suppose if you are taking a f of x which is in this form, it means we are having two types of domain finding. Okay, so to find the domain of the function, the domain will be like set of all x such that g of x should be greater than or equal to 1 if a is greater than 1. Okay, so there is a two condition. When a is greater than 1, what would be the domain? When 0 less than or equal less than a less than 1, what would be the domain? Understood? When a is greater than 1, what would be the domain? When 0 less than a less than 1, what would be the domain? See here, this is a function which is root of log of x minus 4 base 10. Here the value of a is this base. The value of a is equal to 10, which is greater than 1, right? Which is greater than 1. Therefore, here the g of x value would be like what? X minus 4. X minus 4. So, what you have to do is, here you have to consider it like g of x should be greater than or equal to 1. X minus 4 should be greater than or equal to 1. Understood? See, f of x as root of log g of x base a. Here the domain we have to consider when the value of the base is greater than 1 means it's like g of x should be greater than or equal to 1. So when the function is like this, no, so a value would be like 10 and g of x value will be like x minus 4. Then what we have to do is g of x should be greater than or equal to 1. Likewise you have to consider. Therefore the g of x should be greater than or equal to 1 plus 4. X should be greater than or equal to 5. Therefore, the domain will be like 5, infinity. The domain will be like 5, infinity. Understood? Which is greater than or equal to 5. No, that's why. See here. Here the base is 1 by 2, which is less than 1. Suppose when the value of a is 0 less than a less than 1 means what we have to do is, here the value of g of x will be like x minus 6. Right? Here the value of g of x is x minus 6. For this, what you have to do is, we have to consider like this, 0 less than g of x less than or equal to 1. So, 0 less than g of x is x minus 6 less than or equal to 1 will come. Here bring this minus 6 this side, this side. So, 6 is less than x less than or equal to 7 will come. How means, here I am having minus 6, no, I have to bring this to 0, no numbers. So, I have to take plus 6 plus 6. Plus 6 this side also. 6 plus 0 is 6 less than x less than or equal to 1 plus 6 is 7. So here the domain will be like, I have to consider the value, I should not consider the value of 6, but I have to consider the value of 7. Here for this 7, no, I am having equal to symbol, so it's like closed bracket will come. It's like open bracket. Domain of the function should be like 6 comma 7 will come. Understood? So here finally we are having two types of domain finding when the log inside this root, when the base is less than or greater than 1, and when the base is 0, less than a, less than 1. Okay, likewise we have to find. Thank you for watching.